combining some ideas from the past lessons. In our first type of problem, we are given a point that it says is on the terminal side of an angle in standard position. So yesterday we learned how to graph angles, but instead of us being given a degrees for how big this angle is, we're given a point where this angle ends. We're told it ends at -4. So I begin by plotting that point. Then yesterday it said that angles were always connected to the origin. So this would be our angle. And what I'm going to do is then connect that angle to the x-axis. Always connect to the x-axis regardless of where it seems to be closer to. Okay, always connect to x. Theta is the angle by the origin that is enclosed in the triangle. So theta will always be by the origin and x-axis. We can then label the lengths of the sides of this triangle. We went over 3 spaces and 4. We are going to use negatives. They denote direction. So even though we're thinking about a length, we'd say it has a length negative direction. Then, a couple days ago, we learned how to find a third side of a right triangle, or we reminded ourselves how to do that. How do we do that? Pythagorean theorem. So we will apply that here. 3 squared plus -4 squared equals c squared. 9 plus 16, -4 squared, is positive 16. Angle.
We safely assume that would be 5.
Yes, if you see a 3 and a 4 on perpendicular triangle, you can definitely assume, it's not even an assumption, you can definitely know that the hypotenuse will be 5.
Is for stuff like this, will the theta always be the angle at the origin?
Theta will always be at the origin next to the x-axis. The question says, evaluate the 6 trig functions of theta. So that's something that we talked about back in the first lesson of this chapter. To do that, we needed to know the relationship of the sides of the triangle according to theta. So what kind of a side is 3? Like opposite, adjacent, hypotenuse? Adjacent. It's the adjacent. And what kind of side is -4? Opposite. And 5 was the hypotenuse. And by the way, a hypotenuse is always positive no matter what direction it looks like it's going in. Up, down, right, left, diagonals, always positive for a hypotenuse. The sides can be negative, but a hypotenuse will always be positive. So then we want to write our 6 trig functions according to this triangle, Krakatoa, that we learned a couple days ago. So is opposite over hypotenuse, so that would be -4 over 5. Hypotenuse would be 3 over 5, and tangent is opposite over adjacent, -4 over 3. Then we have 3 reciprocal functions, where we flip over the first 3. Sine flips to make cosecant, cosine flips to make secant, and tangent makes cotangent. Connect the origin and the x-axis, always the x-axis. Find the third side of the triangle, and write out the 6 trig fractions for SOHCAHTOA. Questions? Go ahead and try the next one. We begin. Up 12 units. Connect to the origin and the x-axis. theta will always be next to the origin inside of that triangle, so it should always be next to the x-axis. Label the sides of the triangle according to the point that was plotted. Equals c squared. Results in a hypotenuse of 13. Label the sides of the triangle according to the relationship with hypotenuse. Question.
Does it go 12 and 5 of the adjacent and opposite, or is that the correct way?
5 has to be the adjacent and 12 has to be the opposite. It does matter. It's according to the relationship with the theta angle. So when theta is at the origin, opposite means point directly across from that angle. So 12 has to be the opposite. Adjacent means next to, so -5 is the one that's next to our angle. It makes a difference because then when we go to calculate what sine is supposed to be opposite over hypotenuse, and we need the opposite to be 12 so that we all get the same thing. And then cosine would be adjacent over hypotenuse, and tangent is opposite over adjacent. The other three flip the first, so cosecant is 13 over 12. Secant is 13 over -5, and cotangent is -5 over 12. Questions? Plot the point, connect to the origin and x-axis, theta goes next to the origin. Label all 3 sides of the triangle using Pythagorean theorem to find the missing side. Label opposite, adjacent, and hypotenuse. Write fractions using SOHCAHTOA. That's the first type of question. Yes.
Will the things in our home be this plane here?
Your homework may not necessarily give you integer hypotenuse values, in which case you would want to simplify square roots the way that we practiced.
And then you're fine with the square root?
Yes, and then square roots may stay on the bottom as before. Yep. For our next group of problems, we're going to need to draw a picture. So we're going to label our axis angles. So measuring in degrees going around, I would start at 0, and then measure up to the top would be 90, around halfway would be 180, 3/4 of the way around would give 270, and all the way around would give me 360 degrees. Yesterday, we talked about how to graph in radians. How many radians were in a full circle? 2 pi. So how many radians would be in half of a circle? 1 pi. So 180 was the same as pi. What comes halfway between 0 and 1 pi? A half of pi, or pi over 2. And halfway between 1 pi and 2 pi is 1.5 pi, or 3 pi over 2. So these are our special angles around the axes in both degrees and radians. Then we are going to draw a circle with a radius of 1. I cheated. I have a circle drawing tool, so I get to cheat a little bit. We are going to label the points where the circle hits each axis, assuming this circle has a radius of 1 unit. This is called our unit circle. So on our x-axis, if I have a radius of 1, that point would be over 1, up 0, like x comma y. At the top, we would have gone over 0 and up 1. To the left, we would have gone back 1 and up 0. And on the bottom, we went over 0 and down 1. So we're using what is called a unit circle, a circle with a radius of 1, and naming what those points would be as it hits each axis. Each of those points has trigonometric significance. Each of those points gives us the cosine of the angle and then the sine of the angle, alphabetically, just like x comma y. So we can find the cosine of one of those angles by taking the first part of the point, the sine by taking the second part of the point. For tangent, tangent is equal to sine divided by cosine. We will use this diagram to solve problems, and you need to be able to recreate this diagram on your own for the test on this material. This diagram is necessary. The next type of problem we're going to look at in the test. So you need to know how to recreate this drawing. Question?
The xy cosine sine. What is that?
In each of these points, that's like the x value gives of that angle, and the y value of that sine of that angle. Yep. So our next question, to use this diagram to find the 6 trig values for 180 degrees. So what we're going to do is think about 180 degrees being out to the left of that circle, and that point that was on the 180 degree line was negative 1, 0. That point gives us the cosine and then the sine, and tangent is equal to sine divided by cosine. So we want to list all 6 trig answers, as we did in the first ones. Sine, cosine comma sine, so sine is the second part of that point, so sine is 0, the second value in the point. Cosine is negative 1, the first value in the point. So the point gives us the cosine and the sine alphabetically. Cosine is the first part of the point, sine is the second part of the point. Tangent is sine divided by cosine. What is 0 divided by negative 1? 0. 0 divided by anything is 0. Then we're going to consider our reciprocals. I'm going to begin with cotangent because it was already a fraction. So if I flip that over, I get negative 1 over 0. What happens when I divide by 0? Yeah, the world ends. By 0 is a big no. By 0 gives an undefined answer. One was over 1 and flip that over, so that's 1 over negative. Still over the 0 of tangent, I got undefined. When I flip over the 0 of sine, I will also get undefined. Whenever you flip over a 0, undefined. Okay. Ones will say ones, negative ones will say negative ones. Zeros will become undefined when you flip them. And if you have an undefined and you flip it over, it will become 0. Those will always interchange when you take the reciprocal. Questions? Try the next one. For this one, we're looking at the angle pi halves. So find the angle pi halves on your circle and find your 6 trig answers for pi halves. Again, by recreating the part of the diagram that will help us, pi halves is the same as 90 degrees. So that's on that vertical angle. That point is 0, 1 over 0. So the cosine is the first part of the point, which is 0. The sine is the second part of the point, which is 1. Tangent is sine divided by cosine, which turns into what? Undefined. We take our reciprocal. 1 is still 1 if you flip it over. It becomes undefined, and undefined becomes, if I flip over that fraction, I get 0 over 1, so undefined will become 0. Okay, when we take a reciprocal, undefined will become 0, and 1 will stay 1. Negative 1 will stay negative 1. Questions? A reference angle has 3 important characteristics. It is always acute. What does acute mean? Smaller than 90. It is always going to be positive, and it will always be next to the x-axis. A reference angle is acute, it is positive, and it is next to the x-axis. We find a reference angle by graphing. So yesterday we learned how to graph. If I want to graph 320 degrees, I begin at the positive x-axis, and which direction do I go? Counterclockwise. 320 degrees will end where?
40 degrees before the x-axis.
40 before the x-axis. That 40 is the reference angle. That number that we were putting into our graphs yesterday is the reference angle. A reference angle should be positive, acute, and next to the x-axis. That's why I was asking you to put that value next to the x-axis yesterday and not the y-axis. To graph in radians. How big was a whole circle in radians? 2 pi. So half of a circle is pi. And in this question, we're thinking about dividing pi up into 6 pieces. The denominator, pi 6, we want 6 pieces in each pi. So I want 6 pieces in each half of the circle. Since pi is half of a circle, I want the denominator number of pieces in each half of the circle. So 6 pieces on the top half, 6 pieces on the bottom half. We begin at the 0 line, just like we did yesterday. This says negative, so we're going to go around backwards. 5 pi 6 pieces, so we're going to go backwards 5 pieces. When we land here, how big is that angle? 30 degrees, because 180 divided into 6 equal pieces makes each piece 30 degrees. Divide each half of the circle into the number of pieces in the denominator. Graph around the number of pieces the numerator says, and then do the division to see how big the resulting angle will be. Land where? I want to cut each half of the circle into 4 pieces. This is negative, so we're going to go around backwards. The numerator number of pieces, 3. And how big is that resulting angle? 180 divided by 4 is 45. As a heads up, we will often they will be a special angle for us, but they are the most difficult to graph. Because if I cut each half of the circle into 3 pieces, the vertical line is not helpful. So when you cut into thirds, you want to ignore that vertical axis because it doesn't count as a piece if I'm trying to cut into 3 pieces. So I want to go around 2 pieces. How big would this reference angle be? 60 degrees. Why do you think this is going to be an angle we graph a lot? 30, 60, 90 triangle that we learned in lesson 1. So for tomorrow, it would be really helpful if you remember your 30, 60, 90 patterns and SOHCAHTOA, because we will be combining those ideas in tomorrow's lesson.
Look how big the place is.
In our next lesson.
We should go outside.
You do not have any homework